a review on the entire unit, which is called exponential functions, okay? It's gonna start off pretty easy, but then it's gonna get harder and harder and harder. Like you see all these questions, they're all 2-second questions. If you remember the laws, what's the answer to A? Here, I'm gonna give them to you if you don't remember them. Well, it's just these three are the main ones, right? These three. So you have a multiplication, you have a division, and then you have like a double power. And those are the rules. So what's the answer to part A? They're being multiplied, okay? If you don't see, if you have multiple brackets, then those brackets are being multiplied. So what's the answer to A? It's going to be 5 to the power something.
5 to the power of 8.
Yeah, easy, right? B.
8 to the power of 1.
Yeah. C.
Does the exponent apply to both numbers in the bracket?
Yeah, so look at this. No, it does not. It only applies to the exponent.
2 to the power of 12.
Right. Okay, you understand this? Then D. It's going to be something over something in the very first step, and then we can kind of play around with it. Again, it's the rule of power of a power. It's going to be both 7 to the power something in the numerator and in the denominator.
27 and 24.
Yeah, 27 and 24. And now this one's bigger, you just subtract them, you get 7, 3, okay? What about E? I'll give you the top, give me the bottom.
10 to the power of 9.
Yeah, good. And then you see it's a division, then you would subtract, okay? 10 power 3 and you're done. All these are like 2-second answers. But I guess it does get a little bit difficult if you look at here. Nothing changes, it's the same rule, okay? It's the same exact rule. But we're gonna treat -4 as the base. So you see in the numerator here, you have -4, 5, -4, 3. So what do you get in the numerator? Again, they're being multiplied. Just like we did before, nothing fancy. What would we do if it was like this?
You add?
Yeah, same thing here. So what do we get?
8.
At the bottom, you have a 6, you subtract, you get -4 squared, you're done. Here you have a power of a power, what do we do?
You multiply?
Yeah, so what do you get? 2 over 5 to the power of 6, you're done. Okay, easy as that. It's one step actually. Now here are these, the same things, okay? Now we're gonna do them with letters. It's the same exact thing, nothing changes. Here, look at this, 6 over 3, that's A2. We have x5 over x2, so how many x's do we have?
7.
No, it's being divided, right? It's not x5 times x2, that would be x7.
Oh, 3.
3. What about y? How many y's?
Also 3.
Yeah, and you're done. Look at B. What do you think the answer to this is? It's gonna be a one-step answer.
Is it just 4?
For B?
Like to the power of 4?
Okay, so this is how you do this, all right? You have -x to the power of 1, yeah? And then that's to the power of 2. If you open this, what do you get? If you use the power of power rule. Yeah, so it's -x squared. And What does that mean? That means you have a negative sign being squared and then you have an x being squared. Okay, any negative thing you have here, and when the exponent is even, okay, when the exponent is even, it kills the negative sign. So in this case, you have negative x squared, it's just going to be positive x squared. Like
Okay.
negative 2 squared is a 4, right? 2 squared is a 4, and negative times negative is a positive. So you have x squared, okay? What about y? How many y's do we have?
2.
So you have y squared being squared.
So 4.
4. Okay, it's just the power of a power rule here. Let me do another one. I'll give you one of them. B will be 9. What else is the answer to this?
A to the power of 6.
Yeah. What about the number?
4. I mean, no, wait.
Not 4.
8.
Positive 8 or negative 8?
Positive.
No, it's an odd exponent, yeah? So that's the same thing as this, negative 2 cubed, which is negative 2 times negative 2 times negative 2. The number is 8, but you have 3 different minus signs, odd number of minus signs. That means it's negative 8.
Okay.
All right, again, D is the same thing. We're going to do this. We're going to clean up the inside first. The numbers, you can't really divide them. We'll just leave it as it is. How many A's and how many B's?
1A
Yeah,
and 1B.
no B,
Oh,
right? B over B, B to the power of 1 minus 1. It's a B0. You can ignore it. There's no B's. And then when you open this bracket, look at this. This applies to negative 3 over 5. It also applies to A. So you get A cubed, okay, A power 3, and then you would get negative 3 over 5 to the power of 3.
okay.
Which is, I mean, you can kind of do this. Negative 3 cubed is 27. Again, this 3 applies to the negative 3 and also the denominator 5. And 5 cubed is 125, and that'll be the final answer. Let's look at E. I'll give you one of them. You're going to give me the other 2.
R to the power of 6.
Yeah,
And 64.
yeah, good. That's it. They're all one-step answers, literally one-step answers. Okay, this is where we had some issues yesterday. And it's also a one-step answer, but what's 4 to the power of negative 2? If you look at here, what's 4 to the power of negative 2?
16.
No.
Oh, you flip it first?
Yeah, you flip it first. You're gonna throw it in the denominator to make it positive, and then you get 1 over 16. Negative 3 to the power of 4. What do you think that is? So that's negative 3 being multiplied 4 times, right? Like that. That's what it means. You have negative 3 times negative 3. What's that?
9.
9. And then you have 9 times another negative 3 times negative 3, which is another 9. You get an 81, okay? Which is what 3 power 4 is. 3 power 4 is 81. Now look at these C, question C, and look at the difference. Here for B, the answer was positive because there's an the 4, yeah, the power 4 applies to the negative sign. But here in part C, the 4 only applies to 3. It does not apply to the negative sign. That's why it's not in a bracket. So for C is the answer positive 81 or negative 81?
Negative.
Yeah. How do we do D?
Um, 1 over 3 to the power of 4.
Yeah. And we know 3 to the power 4 is 81, so it's 1 over 81, yeah? E.
You put it under a 1?
You could, but you could also flip it, right?
Mm-hmm.
You could like kind of flip this, and then that exponent will be positive. Remember that rule?
Okay. Mm-hmm.
And then you have a -3/1, that's just -3. You can ignore the 1. What's -3 to the power of 4 in a bracket?
Positive 81.
Which is the same thing as B. This one says write the following as a power with a negative exponent. Here, I'll do this one. This is 3 power 5, I think. Yeah. Okay. And then we bring it up, it becomes 3 power -5, like that. How do we do
Mhm.
A?
1/6.
1/6 squared. Right, 36 is 6 squared, and then you move it up, you get a negative exponent. Because it says right using a negative exponent. What about C? It's 4 cubed, okay? 64 is 4 cubed, and then you just bring it up with a negative exponent. What about D?
Um, I'm not sure.
How about we do this? 0.1 is 1/10, yeah?
Mm-hmm.
Which is 10 to the power -1. The 0.01 is just 1 divided by 100, which is 10 to the power -2. You count how many digits you have after the decimal. Here we have 1, 2, 3, 4 digits after the decimal, yeah? So that must be 1/10 to the power of 4. Bring it up, you get 1 to the power of -4. 10 to the power -4.
Okay.
Same thing, we don't have to do this. Let's try this one. Just gonna be a little bit trickier. It says evaluate. What do we do for A?
What happens to the exponents?
So what's 3 power 0?
1.
1. What about 3 power -2?
Positive 9.
Wrong. 3 power 2
You
is
put it
9,
under.
okay? Yeah, so it's gonna become 1/9, right?
Mm-hmm.
1/9. Remember that negative exponent first, flip it. And now we can just take the LCM, the lowest common denominator. So this one doesn't have anything, so it has a 1, right? So we need to multiply this by a 9 and this by a 9. So you get 9/9 plus 1/9, which is 10/9. Okay?
Mm-hmm.
You want to write it as a mixed fraction, it's going to be 1 and 1/9.
Okay.
Okay, this is from your grade 8 stuff that we did a while back. Pretty simple. B, what's 2 power -3?
Um, 1/8.
Yeah, good. Similarly, 2 power -5 is going to be 1/32. Now, how do we add these two? What's the common denominator between 8 and 32?
You can multiply 8 by 4.
Yeah, that's good. So you multiply by a 4 on the bottom. That means you have to multiply by a 4 on the top. So you have 4 on the 4/32 plus 1/32 and 5/32. Cool.
Mm-hmm.
Let's do a couple of these. It says write the following as roots. So we have to put this in a rational form, okay? With a square root or a cube root or anything. So 64 to the power of 1/3. We know this is going to be a root. What root? A third root. Yeah.
Mhm.
So what's the third root of 64?
How do you figure that out?
Something to the power of 3 is 64.
Uh,
It's a 4, okay? It's a 4. Cool. 4 power 3 is 64. That's why the cube root of 64 is a 4. You got it?
I'm sorry, my brother barged into my room.
Okay, no worries. So it says without a calculator, and this is what we're gonna kind of try and train you on, okay? Like without a calculator. You can always use a calculator, but if you depend on it, then your mental math game is not gonna be strong. And yeah,
Mhm.
it's good to have like good mental math so you can do calculations on the fly, especially in real life. All right, so like an example would be this. You're driving in a car, and then you see some other guy up ahead. There's like a crash or something, right? And you're on a highway. You're traveling very fast, and like, how quickly should you brake so you don't barge into them? Stuff like that. Anyways, let's do B, okay? We're gonna try and not use a calculator. Now, if I write this as a root, what does this become?
Cubed.
Cube root of what?
64 to the power of 2.
Right, and then you see that power 2, we can put it outside, okay, like that.
Mm-hmm.
It's gonna be cube root of 64 to the power of 2. We just did this before. What's a cube root of 64? It's a 4, right? See this? From part A, cube root of 64 is a 4, and then you square this, you get a 16.
Mm-hmm.
C, cube root of negative 64. What is that? We know cube root of positive 64 is positive 4.
Is it going to be negative?
Yeah, it's gonna be negative 4. You can always double check, right? Negative 4 times negative 4 is positive 16. And if you multiply this by negative 4, you get negative 64. So that means negative 4 to the power of 3 is negative 64, okay? Which is why the answer is negative 4 there. D. Now be careful, we have a negative exponent. What do we do first?
You flip.
You flip it, right? And that's the same thing as cube root of 64. And we know this is 4, and you're done. 1 over 4, final answer. Yeah?
Mm-hmm.
Okay, E is gonna be tricky. Not because the math is hard, it's just because if we rewrite this as, we're gonna rewrite this as a square root of negative 64 cubed, okay? Like that. It doesn't matter which one you do first. You can always cube it first and then do the square root, okay? But because if you cube 64, you're gonna get a giant number, and we don't know what that is. So this way would be better. And now this is a trick question, okay? You're gonna have to kind of think about this. What is a square root of negative 64?
Um, how does that work?
Is it 8? No, right? Because 8 squared is 64. Is it -8? What's -8 squared?
Positive
Yeah,
64.
it's still positive 64. So what is the square root of -64? Does not exist. That's it. We can't solve this because it does not exist. Okay?
Mhm.
Basically, any you see this root, if this is even root, like 2, 4, 6, second root, fourth root, sixth root, and then you have some negative number in here, doesn't matter what the number is. If you have some negative number in there, you can't evaluate this. Okay? If you plug this in a calculator, it's going to give you error 2. It is unable to perform this calculation because it does not exist. It's like trying to divide by a 0. What's 1 over 0? Can't do it either.
Mhm.
Cool?
Yep.
That's it's funny because you can technically evaluate this, but to do that, you're gonna have to forget everything you know and get out of the real number system that we're kind of used to. Real number system is everything from -infinity to positive infinity, like 10 billion, pi somewhere there, -1 over pi somewhere there, all this stuff. To solve that, you're gonna have to get out of the real number system, go into something, and this is we're headed off in a tangent here. Maybe I've talked to you about this once. And I have to go into the complex number system. You know, there's a constants in any form of math, right? In real number
Mhm.
system, the one that we've seen a lot of is a pi, and that's like 3.141592, yada yada. It's an irrational number, but that's not the point. The point is it's a constant. And we have very many constants in the real number system. In a complex number system, we have every constant from the real numbers plus a new constant which does not exist in the real number system, which is called I. Okay, this is a constant denoted by the letter I. Now, what is that equals to? I is equals to the square root of -1. All right, now let's look at this problem again. We have a square root of -64. We can rewrite this as square root of positive 64 times the square root of -1. And we know the square root of 64 is 8, and we know the square root of -1 is this constant, which is I. This does not exist in the real number system. It's only for complex numbers. And that's the answer to this. At least the square root of -64 is 8i, okay? You won't learn about this for a long time, but it does exist.
Okay.
Basically what happens is the higher level you go in terms of your grades, right? Like 8, 9, 10, 11, 12, university, there will come a point where your teacher will tell you that whatever you've learned before was wrong. And this kind of applies to everything. Like whatever you learned here, at least some things were wrong. And then it again builds upon this. So the fact that this does not exist, it does exist, but not in this plane, okay? The real number plane. Real number plane is the X and the Y axis. Any number here that you can plot. So for you though, if you get a question like this, it's gonna be it does not exist. What about F? 64 to the power of -1 over 5.
Do you put it under 1?
Yeah, you do put it under 1. So it becomes 1 over 64 to the power of 1.5. Now, we don't like decimals either. We don't like negative exponents. We also don't like decimal exponents. What is 1.5 as a fraction? Hey, if you don't know how to do this here, I'm gonna teach you a trick of how to do this. Okay, any decimals into fraction. We have 1.5. We know there's an invisible denominator of 1 there. Yeah.
Mhm.
What we're gonna do is we're gonna kill this decimal. What do I need to multiply it by to get rid of that decimal? By 10.
100.
No, 10.
Oh,
1.5 times 10 is 15. 1 times 10 is 10. What's 15 over 10 reduced?
3/2.
Yeah, exactly. And see, that's what it is. So 1 over. Now again, this one, you can either do 1 over 64 cubed first and then you square root that, but we're not gonna do that because 64 cubed is gonna be a big number. What we're gonna do is we're gonna first square root that, okay? Square root, and then we're gonna cube it. What's the square root of 64?
4.
Square root of 64, not the cube root. Square
Oh,
root,
8.
8. So you have 1 over 8 cubed, and I don't know what that is on top of my head, but that's the answer. Okay. In fact, we can kind of deduce that. That's the same thing as 64 times 8. 64 times 8. Now you remember how to do this? You do 60 plus 4 times 8, okay?
Mhm.
8 times 6 is 42. That means 8 times 60 is 420. And then we do 8 times 4, 32. So that must be 452. 8 cubed is 452.
Mhm.
We're gonna have to do a lot of these guys. Let's see, we're gonna try and do more complex ones now. I'm gonna jump down. All right. Okay, this is gonna be a tricky one. So this is gonna be what we were doing kind of yesterday, exponential equations, when the unknown is gonna be in the denominator. Here's the thing, look at this, y equals 4x plus 3. This is what you're used to, right? It's a linear equation. But in the next level, what happens is y becomes f of x. Y is the exact same thing as f of x. This is called the function notation. It doesn't have to be f and x. It could be like g of k or anything. Okay.
Mhm.
And this will be like 4k plus 3 or something. In here is the x variable. And then the actual x variable is here. So what's the use of this? Look at this. F of 0 is going to be 4 times 0 plus 3, which is just a 3. F of 1 is going to be 4 times 1 plus 3, which is a 7, okay? This is called a function notation. Cool?
Mhm.
You remember how we solved exponential equations yesterday? Guess and check?
Uh-huh.
We're not going to do that today because that I think is a little bit redundant because it can take forever, right? Like yesterday, we went up to like 28 or something. That's not how it's supposed to work, okay? It's not how it's supposed to work. Let's look at this question. There's a better, more efficient way of finding the exact answer. That's what I'm trying to tell you. But you'll only learn about that later. You're gonna first learn about the guess and check, which is, I find really annoying. And you're gonna see what I'm talking about here. So there's an equation. N of t means the number of bacterias, and t is the time that has passed in minutes. Calculate the number of bacteria present initially. Okay, we did this yesterday. What's the time initially? What do we plug in as time?
Um,
It's asking for the y-intercept. On the y-intercept, what is 0? Something is 0. The x value, okay?
Mhm.
The x value is 0. Initially means automatically time is 0. What was the population to start off with? So we're gonna do n of 0 is equals to 1,000 to the power of 2 to the power of 0 over 5, yeah? 1,000 times 2 to the power of 0 over 5. Now 0 over 5 is still a 0. We can do this is a 0. We just can't do it the other way around. You can't have 0 in the denominator, but you can have 0 in the numerator, okay? So 2 to the power of 0 over 5 is just 2 to the power of 0. And we know that's a 1. So therefore, initially there were 1,000 bacteria. Cool.
Mm-hmm.
Calculate the exponential growth rate of bacteria. So that means what got added to this? This is initially 1, okay? What did we add to that? For example, here, the growth rate would be 0.05 or 5%. If you have 3.55, the growth rate would be 2.55 or 255%. You just subtract 1 from this. So what's the growth rate?
1.
1, right? And what's that as a percentage? Just multiply it by 100. To go from a number or a decimal to percent, just multiply it by 100. Okay?
Mm-hmm.
Now, what does growth rate of 100 mean? 100% growth rate means it doubles. Okay, so it's doubling every whatever minutes here. Look at this, 3, what's the growth rate? It's gonna be something in percent.
300.
200, you gotta subtract 1. Okay, growth rate is 200%. What does that mean? That means it triples. Okay,
Mm-hmm.
growth rate of 800% would be like if it was a 9 in there. That means it goes 9 folds. Cool.
Mm-hmm.
How many bacteria were present after 0.25 hours and 1 hour? So what do we plug as T? They want the bacteria, which is the Y variable, yeah? They've given us X variables here. So what do we plug in as T for 0.25? T is time, yeah?
Mm-hmm.
In fact, T is time in minutes. How many minutes are there in a quarter hour?
15.
Yeah, good. So you plug X as 15 and you're done. So it's 1,000 times 2 to the power 3, which would be 8,000.
Mm-hmm.
What about for 1 hour? What do we plug as T?
60 minutes.
Yeah, exactly, 60 over 5. Okay, so you plug 60, and that's going to be 1,000 times 2 to the power 12, whatever that is. All right.
Mm-hmm.
Part D is asking us for the domain and range. Again, let's look at this equation. It's asking us for the domain, which means what X values can it take? It's also asking us for the range. What Y values can it take? Now, what does that mean? That means, are there any restrictions on the X values? Are there any restrictions on the Y value? What do you think? Think about it this way. Can X be 5? By X, I mean T here, okay? Can that T be 5?
Yes.
Yeah. Can it be 5,000?
Yes.
Can it be 50 million?
I guess so.
It can be. Can it be 0?
Mm-hmm.
Yeah, that's the initial, right? But what about this? Can it be -1?
No.
No, it cannot. So what does that mean for the domain? The X, or in this case, it's the T. T has to be strictly greater than or equals to 0.
Mm-hmm.
And that's the domain, okay? It basically tells you what possible values, X values, the function can take. Now, similarly, we're going to ask questions about the range. Again, remember, range is the number of bacteria. Can it be 0?
Yes.
No, it cannot be. Why can't it be 0? Because initially, we already have 1,000, right?
Oh.
Cannot be 0. Can it be 999?
No.
No, it cannot. We know it can be 1,000 and it can be anything greater than 1,000. So it's going to be n of t, that's the y variable, right? Is going to be strictly greater than or equals to 1,000, and that's the range.
Mm-hmm.
You understand that?
Yep.
So that has to do with domain and range. This question was asking us for 1 hour. That means the domain is t is between 0 and 60 minutes. And the range is whatever the population was for 1 hour. But usually they will ask you for the function, okay? Let's see. I don't know if I want to kind of introduce you to this. Let's do a couple of problems here. I'm going to give this. Okay, I don't know if you remember this, but I'm not going to give you the skeleton thing, but try and tell me whatever you remember, right? A, K, D, C. These are the first questions and where the wall is. What's A in this case? So we're doing transformations.
1.
A is 1. It is not 1. Try again.
-3.
-3. What's K?
There's no bracket.
So introduce a bracket. You won't always be given brackets because I'm trying to trick you. That's what. 4x plus 12. What do we pull out?
A 4.
What's left in the bracket?
X plus 3.
Right. So what's K?
4.
What's D?
3.
Try again. You're comparing this with this, okay? X minus D.
Oh,
What's D?
-3.
Yeah. What's C?
8.
Where's the wall?
At C.
Right. And so the equation of the wall is what? It's a horizontal line. Y equals 8. Okay.
Mm-hmm.
What's the base function?
2.
Yeah, base function is 2. Now we're going to talk about what all these letters mean. What does A being -3 do? It does 2 things.
It's a vertical stretch or a compression.
Which one is it? Stretch or compression? In this case.
Stretch.
Yeah. So it's a vertical stretch by a factor of 3. There's another thing we can get out of this. What's the second thing?
It reflects on the x-axis.
Yeah, good. Exactly. It reflects on the x-axis. And now we're done with A. Let's look at K. What does K being 4 do?
It's a horizontal compression.
Yeah, good. By what? By a factor of 4, okay? So it shrinks inwards by a factor of 4. What does D minus 3 do?
It means you go left.
Yeah, good. Left by 3. What does C8 do?
It means you go up.
Yeah,
by
up.
8.
Up. Just some terminologies here. The wall, that's just the informal way of saying it. The actual thing is the technical mathematical terminology. This is called a horizontal because it's a horizontal line. Horizontal, and that's called asymptote, okay? Asymptote. And then when it goes left, right, up, or down, these are called translations. Not like from Chinese to English or something. Translation means it moves, like it can move either up, down, left, or right. It can move here, it can move here. That's the technical term, okay?
Okay.
So we would say, for this one, left, we would say a horizontal translation, left by 3 units. For this one, we would say a vertical translation, up by 8 units.
Mhm.
All right, now we're going to use the point mapping rule. Point mapping rule says this: any point x, y becomes what? If you remember.
2 to the power of x.
Brave try. No, any point x, y from the parent function, from the Brave function, becomes x over k plus d and ay plus c. Okay, this is called the point mapping rule. And you're going to use this for transformation for literally any function they give you. There's dozens of functions, but nothing changes. It's just that the property of the function changes. For example, the linear line either goes straight up or down, right? That's the property. It's always increasing, it's always decreasing. Whereas a quadratic does both. It decreases up until a point and then it goes back. Exponential function also is very similar to linear. It only does one thing. It's either increasing, called exponential growth, or it decreases, which is called exponential decay, okay? So the transformation of functions is the point mapping rule applies to any function. The only differences between functions is that they have different properties. All right, so in this case, it's going to become x over k. So if we plug in the 4 letters, what does that turn into? Will become x over 4. Okay, you see that? X over k plus what? Actually, this may not be plus.
-3.
Yeah. Now what about the y?
-3y plus 8.
Yeah, good. -3y plus 8. Okay. Now what do we do next? We're going to come up with a table of values for the parent function. Okay, which is, in this case, we know the base is 2, the base function. So this is y equals 2 to the power of x. We're going to come up with the table of values for this one. Now again, we had some issues here yesterday. When x is -1, what is y? We're looking at the base function here.
1/2.
Yeah, good. That's exactly what it is. It's 1/2, which is 0.5. All right. And then 0, from here, it's easy, right? 0 is 1, 1 is 2, 2 is 4. Now what are we gonna do? We are gonna plug and chug, I like to call it. I'm gonna put -1 in there. We're gonna put 0.5 in there as y. And here you can use a calculator, honestly, because these numbers are pretty not nice. So -1 divided by 4 minus 3 gives me -3.25. Similarly, I'm gonna plug 0.5 in there as y. That gives me 6.5. Okay. Then you keep going. So 1 divided by 4 minus 3. That's -2.75, and I'm going to plug 2 in there as y. -3 times 2 plus 8, that's a 2. 2/4 is 0.5 minus 3 is minus 2.5, and 4 in there, -12 plus 8 is -4. Cool? So once you have that, you basically have the question in the bag. You don't need anything else. Just remember the wall is at +8. So we are going to draw a line. I'm going to look at the values. We use a lot of negative x values, so I don't really care about the positive x like that. So what's going on here? So I'm going to say 4 boxes is 1. So that's -1. 1, 2, 3, 4. That's -2. 1, 2, 3, 4. That's -3. 1, 2, 3, 4. -4. And then we go up and down. So 1, 2, 3, 4, 5, 6, 7, and then we go down to -4, 3, -4. Okay, like that. We know where's our wall.
8.
So that's, you see that dotted line is y equals to 8, okay? When you have y equals to something, it's gonna be a horizontal line. If you have x equals something, it's gonna be a vertical line. So we have -3.25, which is here, and 6.5. So there you go, that's our first point. Next point is -3 and 5. Next point is negative 2.75 and 2. Next point is 2.5, which is here, and negative 4. Look at it, just kind of jumps down. See that?
Mhm.
Now we're just going to connect the dots, and we are just going to gently ride the wall. Okay, do not cross the wall. This one you can drag it down, and there we go. That's our transformed exponential function. Does that make sense?
Yeah, it does.
Couple of steps, right? Yeah, you just have to get used to the procedure. It's not that bad. Now I promised you we're gonna learn something new. I mean, I didn't promise you, but I'm gonna tell you something which you might find very interesting. 4 equals 2 to the power of x. How do we do this? How do we solve this exponential equation? If you remember from yesterday. We need to rewrite 4, okay, as, you see this number? 2 to the power of something. What is 4 in terms of 2 to the power of something?
2 to the power of 2.
Exactly. And see, now if you have the same base here, they cancel out. So therefore, x is 2, final answer. Okay. Try this one. 125 equals 5 to the power of x. 125 is 5 cubed, yeah? Boom, boom, gone. X is 3, easy, right? But what if you can't write one in terms of the other? What do we do not? For example, 3 equals 2 to the power of x. What do we do in this case?
Nothing.
No, we do something. The answer does exist. It's not like the answer doesn't exist. Yesterday, what we did was we did guess and check, right? Like, I'm gonna just type these in. So 2 to the power of, well, 2 to the power of 2 is 4. 2 to the power, look at this. 2 to the power of 2 is 4, and 2 to the power of 1 is 2. We need a 3 here, right? So it must be in the middle. Let's try 2 to the power of 1.5. Not big enough. 2 to the power of 1.6. Yeah, 2 to the power of 1.6 is good. Okay. Guess and check tells us the answer is 1.6. Right? But that's not the precise answer. 1.6 is just an approximation. Okay. 1.6 is simply an approximation. The answer is we can be way more precise. So now what do we do in this case? To solve something like this, to solve an exponential equation, we need to look at a different kind of a function. If you have a calculator on you, you'll see there is a button called log on your calculator. It's a scientific calculator, and that's a completely different type of a function. It looks like this. It's the opposite. Actually, it's the literal inverse, it's called. It's the inverse of an exponential function. This is your exponential function. Yeah, it goes like that. There's an invisible horizontal line. The log function is symmetrical, okay? Symmetrical to this. It goes the other way. It looks like this. It's kind of the opposite. It's the exact opposite. Okay, that's the log function. We don't have to worry about what it looks like. But what's so important about log functions? Here, check this out. If you have log of a to the power of b, you see that's an exponent. It has a very powerful property. The exponent drops down. For example, if you have log of 2 to the power of 3, that's the same thing as 3 times log 2. Okay? We know this is an equation. An equation, you can do something on both sides, right? You can add, subtract, divide, you can do whatever you do, as long as you do it on both sides, correct? So what we're gonna do here is we're gonna log both sides. Look at this. Log 3 is equals to log of 2 to the power of x. Cool? Now what's the point of doing this? Look at this. The exponent, you see, using this rule, the exponent, we can drop it down here. So it becomes x times log 2 equals log 3. And then divide both sides by log 2, you'll get the answer. Do you have a calculator on you? Why don't you try this? Log 3 divided by log 2.
1.58.
Yeah, there we go. That's the more precise answer. We say it was 1.6, but that's a guess and check. So there you go. Log, a very powerful function. And when you have an exponential equation, you sometimes, if you can't write it in terms of the base, then you go the log route, okay? So that's something new here. Let's see what questions they have for us. We did that question. Let's talk about half-life, which is where this is going to be used. Like I'm going to give you an example of where this function comes into play. So you see, this is a half-life question, and half-life is in this form. How do I denote this? I can just call it A, I guess. The amount, okay, the amount after t days is equals to the initial amount times 1/2 to the power of time over half-life. Again, don't worry too much about this, but this is the formula, okay? I'm going to give you the equation here. It's going to be A of t is equals to 320 times 1/2 to the power of t, which is, we don't know that. I guess t is just t, but we do know h. That is 8. Now, if I asked you, after 20 days, how much mass is there? What's the amount after 20 days? How do you do this question? Again, the y value is the mass after 20 days, okay? The amount after 20 days. So it's very simple. You just plug t as 20. 1/2 to the power of 20 over 8. Okay, like that. This one you're going to have to do it in a few steps. So what's 20 divided by 8? That's 2.5. So we have 1/2 to the power of 2.5. And then that's 0.5 to the power of 2.5, which is 0.176 times 320. So you have 56.6 grams after 20 days. Do you see that? You just plug. What if I said after 100 days? What's the mass? What do we say? What's the amount left after 100 days? What do we do?
You just plug it in as t.
Yeah, you just literally plug it in as t, okay? But what if, now see, this is where this is gonna come into play. What if I ask you, after how many days will the mass be 100 grams? So I'm asking, what's the t value when the y value, in this case, A of t is 100? Let's look at this. So we know A of t is 100, the y value, that is equals to 320. Again, that's 1/2. You can write that as 0.5. It's always going to be 0.5 for these half-life questions, which is what exactly is half-life? Let's talk about that, and then we're going to quickly do this problem. Let's say you have some metal, okay? Like this, anything like that's radioactive, like uranium and stuff like that. Anything that's radioactive. What happens is over time, it loses its mass. It's going to release radiation and it's going to lose its mass, okay? So let's say it started off with 20 grams and let's say 10 grams. It took it 2 days to get to 10 grams. That means its half-life is 2 days. And then after 2 more days, it's going to half again. It's going to be 5 grams. And then after 2 more days, which is total 6 days here, its gram is going to be 2.5. And then just like that, after every half-life days, its mass goes down by half, okay? That's what half-life is. And every radioactive substance has a half-life like this case. So now the question is, how do we solve this exponential equation? What do you think? What's the first step? Divide both sides by 320, okay? 100 divided by 320, and that gives me 0.3125 equals 0.5 to the power of t over 8. Now, we can't write 0.3125 as 0.5 to the power of something. So what do we do in this case? we take logs on both sides. Like that. And what's the point of using logs? It's because it allows us to bring the exponent down. You see, like that. Now what do you do? What do you think? We're trying to solve for t. We're trying to solve for t. That means we need to get rid of this guy, the bracket, and this 8.
You multiply
By what? By 8?
Mm-hmm.
Yeah, that's right. You do the opposite operation. You multiply by 8. And then? How do we get rid of this?
You divide.
You divide. Exactly right. Boom. So you have 8, and you can now, it's a calculator play, 8 times log of 0.3125 divided by log of 0.5. And that gives us the time exactly, it's 13.4 days. So after 13.4 days, this mass that was initially 320 grams would have decayed to 100 grams, given that its half-life is 8 days.
Mm-hmm.
Did that kind of make sense?
It did.
Yeah, it's just a little bit new, right? It's something new and it looks complicated. But don't worry, like with exponentials that we did, you're eventually gonna get a hold of this. And again, it's just solving, this is a linear equation. It's always gonna be a linear equation. It's nothing, no quadratics, no quadratic formula, no man method, nothing, because the variable here is t, right? So that's just gonna be a linear equation. The log things, these are just constants. They'll always be the same, okay?
Mm-hmm.
So if you don't completely get it, don't worry about it. But see, that's the trick. When you're trying to solve an exponential function, but you can't write one in terms of the other, you're going to have to go through the log approach, okay? Which is a function.
Okay.
It's not like log means wood in real life. It's not a wood. It is a function. And there's way many more functions, but I think we've basically done most of the important high school ones.
Uh-huh.
All right, let's call it a day there.
All right. Thank you.
All right, see ya.